Hey, happy Friday. This is the last video of the week. Obviously, it's Friday, right? Um, we are starting to solve quadratics by factoring. So there was a reason that we factored before, not just because it's, in algebra, but we are going to use factoring to solve quadratics. So yesterday, hopefully you watched the video on the introduction to what a quadratic root is. Remember, it's the x-intercepts. They're also called zeros, solutions, roots, and hopefully you practiced a little bit of them using the discriminant, and hopefully you practiced and saw how we work them out. Plug in an x, get your y's, and then where your basically your x-intercepts are where your solution. So today we're going to solve by factoring, so no more graphing, and then we're going to relate that back to what those solutions are. So I want you to complete the even numbers. Actually, complete as many as you can so you get enough practice. Remember, your Math Excel is due today, and that had to do with a lot of vertex form and transformations. As you saw, there were 3 days worth of that. So there are 2 Kahoots for you to do on Edmodo. I only saw a couple of you come to office hours this week for help, so hopefully this will get done. Your progress reports are done today. Let's make the next 4 weeks the best. Stay tuned for a surprise. That's all I'm going to say about that. Okay, let's get started. So here's the page that we are on for solving by factoring. Now, it says in many cases we can find the solutions, aka roots, zeros, or x-intercepts of a quadratic equation by factoring rather than graphing. Follow the steps below to find the solutions. So remember, a solution is an x-intercept, okay? So what if you're not graphing? Well, this is how you do it. We want to make sure the quadratic equation is set equal to 0. If it is not, you need to make it equal 0. So we're going to factor, I don't know why this says the left side, but you're going to factor, obviously, the side where the work is. So this is going to be the right side. We're going to make this equal 0. So this is going to be 0 equals x squared plus 3x minus 10. And then we are going to factor. So 0 equals what multiplies to give you negative 10, but would add to give you positive 3. That would be plus 5 and x minus 2. And then we're going to set each factor equal to 0 and solve. So what does that look like? That looks like, well, x plus 5, and I'm going to take away the parentheses. X plus 5 equals 0. X minus 2 equals 0. So we're going to solve each factor for x. So this is a factor and this is a factor. So in this case, I'm going to subtract 5. We get x equals negative 5. In this case, I'm going to add 2. So that means x equals 2. In our answer, we know that our solutions are negative 5 and 2. We could also write these as coordinates. The x-intercept is when y equals 0, so we can do negative 5, 0, and 2, 0. This is the more accepted way, but if you wanted to write them as points, you could also do that. So what I'm going to do is I'm going to go through your homework and let you practice the examples because you have the answer key to check them on your own. So I'm going to go through and do the homework. So yes, that would be these pages. Homework number 5, and I'm going to do the odd numbers. So first step is to make sure you are equal to 0. This one is. So we're going to factor. This is a regular trinomial, so we're going to say what multiplies to give us 12 adds to be 7. That's x plus 4 times x plus 3 equals 0. Now we're going to split them up and do x plus 4 equals 0, x plus 3 equals 0, and solve. So in this one, you're subtracting 4. This one, you're subtracting 3. It's pretty straightforward. Answer, negative 4, negative 3. This one was a really good curly braces. Bracket, brace, who cares? So our answers or our solutions would be negative 4, negative 3. And on a graph, right, remember our graphs, that would mean that we would have an x-intercept at negative 4 over here, and we'd have an x-intercept at negative 3. So this particular one would be very thin. Yeah. Hold on one second right here. I want to graph this. What if we did it on Desmos? Hang on. Okay, so this is going to be y equals x squared plus 7x plus 12. There we go. So our vertex is at negative 3.5, negative 0.25. That's why our x-intercepts are so close. So it's not that it's really skinny, it's just very, this vertex is very fractional and it's very close to the x-axis. So normally we'd see one like a little more down and the solutions would be a little more spaced out. However, you knew that this one, and I knew that this one wasn't very narrow because our x squared didn't have a coefficient. But let's see if it did. If it did, like a 5 or something, that would change the whole thing and make it very skinny. Okay, so as far as we know, this is our graph. A little tangent. Okay, so number 3, we need to make sure that it is set equal to 0, and it is, and we're going to factor. So we need something that multiplies to give us negative 30 but adds to be negative 1. That's easy. X minus 6 times x plus 5. Now we're going to separate them and set them each equal to 0. When you get better at this, you'll start to just do it in your head. And you won't need to so much write it out and separate them like we're doing right now. Okay, so our answers are 6 and negative 5. There we go. Okay, so what do we do? I'm so like cramped right now. So what do we do when, hold on. What do we do when it's not equal to 0? Well, we have to make it equal to 0. So in order to get something equal to 0, I want to take away everything on that side. So this turns into x squared minus 9x, because you know standard form, the x goes before the constant and after the exponent term. And this is minus 10 equals 0. So in this one, you had to set it equal to 0. I want to take everything from that side away and bring it on the other side, so you do the inverse operation. Now we factor. So multiplies to give you negative 10 but adds to give you negative 9. That would be x minus 10 times x plus 9. No, sorry about that. It's x minus, 90. X minus 10 and x plus 1. Hello, sorry. That's going to be equal to 0, and then we set them both equal to 0. Clearly, my head is not in the space for math right now. Okay, so this one's going to be x equals 10. This one's going to be x equals negative 1. Okay, there are solutions. So you can see that this one's going to be very spread out if you wanted to do this. And you know what? We're going to do it. We're going to graph this one. So this one becomes x squared minus 9x minus 10. And as you, I'm getting a pimple, I think. As you can see, this vertex is all the way down here at 4.5, negative 30.25. You see why they didn't have us graph these? Like if someone said a question like solve this equation, just period. Nothing how, nothing what method you use. You would not choose graphing. I don't know anyone in their right mind who chooses graphing as their preferred method of solving anything, because you get messy numbers like these. Like who wants to deal with that? No one. So that's why we have other methods with factoring. So here's one of our solutions. Here's the other solution. And we know that we did it correct. And this is what your graph looks like. Number 7. So we have to move this. Again, it's not equal to 0. So we've got to move. This one, unlike number 5, has another like term on the left-hand side of the equation. So I'm not going to combine 16 with negative 7x. I'm not going to combine x squared with negative 7x. I'm going to put it right under here so I can combine these like terms. So this turns into x squared minus 10x plus 16 equals 0. So now we're going to factor this one. What multiplies to give you 16 adds to give you negative 10. That would be x minus 8, x minus 2. Okay, set them both equal to 0. We get x equals 8, x equals 2. Again, you can check on Desmos to make sure you did that correctly. You got 8 and 2 as your x-intercepts. Okay, oh my gosh, what about one like this or over here where you have 2 terms on the right side? Now, some of you may look at this and be like, oh, I can't do it. But it's not hard. All you have to do is take away both of these things by doing the inverse. So if this is positive, I'm going to subtract. If this is negative, I'm going to add. And I'm going to add it over here and combine it with its like terms. So I'm going to put minus 3x under the negative x, and I'm going to put plus 1 under that negative 46. And I'll do this vertically for this one. Cancel, cancel. So we get x squared minus 4x because negative x minus 3x minus 45 equals, and since everything canceled out, 0. Now we factor. So x, what multiplies and adds? It's going to be 9 and 5. So negative 9 and positive 5. Separate x minus 9 equals 0. This is going to be x equals 9. This is going to be x equals negative 5. 9, negative 5. Okay. So we just did 3 problems where it was not set equal to 0, and it's no sweat. There's no problem making it equal to 0. Okay, let's do the last 5. Okay, once again, this is not equal to 0. So let's make it that way. I see an x squared term, so I'm going to subtract x squared from here. And I'm going to add 8 here. So 2x squared minus x squared is just x squared. The negative 7x comes down, and this becomes positive 12. Cancel, cancel equals 0. That's what you want. Now factor. We need x minus 4 times x minus 3, and then solve. Hopefully you're seeing we add 4, add 3. Okay. This one. So this one is equal to 0, but we've been factoring trinomials. Have you forgotten about the other methods of factoring? This, my friends, is going to be factor with GCF. And you know what? So is this one. So for number 13 and 15, all you need is the GCF. So number 13, this is equal to 0, so that's good. We're going to take a look at these 2 terms because remember, it's 2 terms. If you have 2 terms, it's not a trinomial, so you can't be like, oh, adds and multiplies. So with this problem, we're going to take out, because they both share an x, and then what are we left with? X plus 3. What do we do now? Oh my God, same thing. You have 2 factors. You have an x and an x plus 3, just like you had x minus 4 times x minus 3. These are both 2 factors because why? They are multiplying together. So same way, you set each of them equal to 0 and solve. Well, this one is just x equals 0 because there's nothing to do. And this one you subtract 3, so x equals negative 3. Answer 0 and negative 3. Guys, remember, these are not coordinates. So these are your 2 solutions. This is solution 1, and this is solution 2. Or x-intercept 1, x-intercept 2. Okay, we got to think about a parabola as they possibly intersect at 2 points. Remember, they don't have to. They can intersect at only 1 point. And we'll see that coming up in the future. Okay, so same thing here. Now we have to solve to get the quadratic equal to 0. So let's take away this x term and combine it with its like term. So 6x squared minus 3x equals 0. Again, factor using the GCF. We know both of these share a 3x. And we are going to be left with 2x minus 1, right? Because 3x times 2x is 6x squared. 3x minus 1 is minus 3x. There you go. Next step is to set them both equal to 0 and solve. Now we've got a two-step equation here, so that's a little bit different. This one's easy. When you divide by 3x, it's just equal to 0. This one you add 1, and then divide by 2, x is equal to 1/2. So in this problem, we get 0 and 1/2 or 0.5, what have you, whatever you want to use. You want to see this one? Yeah, why not? So this one, 6x squared minus 3x. Ooh, this one's very narrow because remember, the 6 is your a, so that means it's a narrow stretch. And look, the vertex section is very, very condensed right here. Okay, so look, we've got 0.5 and we've got 0 as our intercepts. And our yucky vertex right here, if we solve for it, would be negative 0.375 as your y. So again, here's your parabola. Best way to solve this is with factoring. 2 more. What about this one? We're going to see these problems next week in another lesson, solving by square roots, but for now we're going to solve it by factoring. And solving by square roots is actually much easier when you have perfect squares, but we'll talk about that next week. So for these two, you're going to factor with the difference of squares. Okay, so set equal to 0, that's good. And how do you factor a difference of squares? Remember, it's a plus b times a minus b. Take the square root of x squared, which is x, square root of 36, which is 6. So x plus 6 times x minus 6. And then you set them both equal to 0. So your answers are basically positive and negative 6. And that's how I want to write it because we will see this in the future, especially with quadratic equations and square roots. This just means positive 6 and negative 6. This is positive and negative, that symbol right there. Okay, again, this is going to be how we're going to solve it in our next lessons about square roots. But for right now, we want to set it equal to 0, so we'll subtract this 1, creating a difference of squares. So again, solve this 3x plus 1 times 3x minus 1. So 3x plus 1 equals 0. If you already see that this is going to be a fraction, congratulations. So what do you think the other one's going to be? Positive 1/3. Oops, I put 1/2. Christian, I saw it, don't worry. So x, or our answers, are positive and negative 1/3. And that's factoring. That's solving by factoring. So we saw trinomials here, we saw GCFs, we saw difference of squares. Hopefully you guys can see what the deal is with that. Make sure they're equal to 0. These numbers, these values give you your x-intercepts. Okay? I hope you have a great weekend. Next week, we are going to solve even more quadratics. Please make sure you do your Math Excel. All right? See ya. Bye.